Hello everyone, myself Michael Ravina, Associate Professor, Department of Computer Science and Engineering. The subject is CS3492 Database Management Systems. The unit is Implementation Techniques. The topic is hashing. Hashing is an effective technique to calculate the direct location of a data record on the disk without using the index structure. Hashing uses hash functions with search keys as parameters to generate the address of a data record. Hash organization. First, bucket. Bucket means a hash file stores data in a bucket format. Bucket is considered as a unit of storage. A bucket typically stores one complete disk block, which in turn can store one or more records. Next one is a hash function. A hash function H is a mapping function that maps all the set of search keys K to the address where actual records are placed. It is a function from search key to bucket addresses. Host hash function maps all search keys to the same bucket. An ideal hash function is uniform. Ideal hash function is random, so each bucket will have the same number of records. There are two types of hashing. First one is a static hashing, then second one is a dynamic hashing. Static hashing. In static hashing, when a search key value is provided, the hash function always compute the same address. For example, if mod for hash function is used, then it shall generate only 5 values. The output shall always be the same for that particular function. The number of buckets provided remains unchanged at all time. There are 10 buckets means the hash function returns the sum of the binary representation of the characters likely. For example, 5 mod equal to 10 mod of equal to 5 mod equal to 3 mod equal to 3. So like this static hashing is performed based on the search key, that is there are 101, 103, these are the search keys. Based on the search key, the hash function, there are 10 buckets means 1 to 9 buckets. So this from using these hash functions, the particular value is stored. Operations. In the static hashing, these operations are possible. First one is insertion. When a record is required to be entered using static hash, the hash function has compute bucket address for search key K where the record will be stored. Bucket address is equal to H of K. Search means when a search record need to be retrieved, the same hash function can be used to retrieve the address of the bucket where the data is stored. Next one is a delete. Delete is a simply a search followed by a deletion operation. Bucket overflow can occur because of insufficient buckets, skew in the distribution of bucket. This can occur due to multiple records have the same search key value. Although the probability of the bucket overflow can be reduced, it cannot be eliminated. It is handled by using the overflow bucket. That is overflow chaining. The overflow of buckets of a given bucket is chained together in a linked list. The above scheme is called closed hashing. An alternative called open hashing, which does not use overflow buckets. It not suitable for the database application. This is the bucket, that is this is a diagrammatical representation of overflow bucket. Suppose bucket 0, bucket 1, these are filled, then the overflow bucket is again goes to the another bucket. That means bucket 1 is filled, then another data comes to the same bucket, means then the value is stored in this linked list structure. Next one is the hash indexes. Hashing can be used not only for file organization but also for the index structure creation. A hash file organizes the search keys with their associated record pointers into a hash file structure. Hash indices are always secondary indices. This is the diagrammatical representation for the hash indices, that is the buckets, and the bucket contains values are stored in the indexes in this way. Dynamic hashing. It is a good for database that grows and shrinks in size. Allows the hash functions to be modified dynamically. It is also known as extendable hashing, is one of the form of dynamic hashing. The hash function generates over a large range, typically 6-bit b-bit integer mean with b equal to 32 bits. At any time using only a prefix of the particular hash function index into a table of bucket addresses. Let the length of the prefix bit I be the 0 less than or equal to I less than or equal to 32. That means in between 0 and 32. 0 to 32. And the bucket addresses of table size equal to 2i. Initially I value is 0. The value of I grows and the bucket addresses table may point into a bucket. Thus the actual number of buckets is less than 2i. The number of buckets is also changes dynamically due to collapsing and splitting of buckets. This is a general extendable hash. General extendable hash functions, and there is next insertion in the extendable hash. Extendable hash can be inserted in this way to split a bucket j when inserting the record with search key value if the following conditions are made. If I greater than ij, that is more than one pointer to the same bucket j, allocate a new bucket and set ij equal to iz equal to ij. Update the second half of the bucket address tables entries originally pointing to the j to point to z. Remove each record in bucket j and reinsert j or z. Recompute the new bucket size kj and insert record in the bucket. This is one way. Another one condition is, suppose if I equal to ij means if I reaches some limit b or too many splits that have happened in this insertion, create a overflow bucket. Else increment the I and double the size. Otherwise replace each entry in the table 2 entries and always next recompute the new bucket address table, and now I greater than ij, so it use the first case above. Next, deletion. Deletion in the extendable hash structure has the same. To delete a key in a value, locate it is in the bucket and remove it. The bucket itself can be removed if it becomes empty. So suppose if any collapsing of bucket can be done, then can collapse only with the buddy bucket having same value of ij and same ij minus 1 prefix. Next, decreasing the bucket address table size is also possible. Decreasing bucket sizes table is an expensive operations and should be done only if number of buckets becomes much smaller than the size of the table.